Is the microphone working? Yes. So hello, everybody. I know the room is big and the audience is not that big, so if you guys want to come closer, would be nice just to be able to see each other. My name is Youssef. I'm here with Stephen, who's going to give you a talk about how to effectively manage the network to meet the needs of your application. So as you know, we have introduced something called the Azure Resource Management Infrastructure for Azure, in which you can describe through templates what the needs of your application are in terms of the resources and how they're composed, and then the system will orchestrate everything for you. Today's talk is about how you can describe the needs of the apps with respect to the network, how the network should look like, how it's structured, and how you can change it either imperatively or through a template, basically, okay? So I'll give you a bit of setup of the basic model, what you can do for the network and the like, and why you would care as a developer. And then Steve will come up and show you the object model, the RESTful APIs, some of the JSON in there, C# and PowerShell, how you can actually use the model, okay? A reminder, please, do submit the evaluation, please. So quick agenda, I will not dwell on this much. Tell you a bit more what's the value proposition for you? Why would you care as a developer to be able to control the network? Give you a very quick view about ARM, which is Azure Resource Manager, the way in which you describe your application, and the way the system orchestrates its deployment and effectively its lifecycle management. Then I'll tell you a bit more about the specific topic for today, which is the network resource provider, which is the resource manager that provides the API in question here. Then we're going to go through hands-on APIs. We'll show you demos, show you code, and we're opening the floor for your questions as well. So why should you care? I mean, we're here writing code at build, right? Well, guys, the reason for this talk, if you want to remember anything here, we want to empower developers to control their own destiny, to write the code quickly, and to configure the environment for their code quickly. This could be in a dev test cycle or even in production. So as you know, we all write services nowadays. It's more like a DevOps model. We write the code, we test it, we deploy it, we monitor it, and we fix it if something goes wrong, and we repeat. In effect, we are sort of removing other folks who we used to depend on to get our applications done. We have tooling, and now we also have a way for you to define the network around your application. In older days, you may be able to write some code, test them on the side, but if you want something real, you have to talk to somebody, get you a network, manage the network, configure the load balancer, you know the story. With this system now, everything is virtualized. Everything's in software. So not only can you write the code for your application, but you can also configure the network to your application's needs, all through software, basically. Lastly, I want to emphasize that the plumbing underneath the cover for you for networking, which can be quite extensive, you don't have to do or know everything about it. You can write an application that lands in Azure in a very simple network, a flat network where every virtual machine or every entity talking to each other. Very simple. You can write an application that requires maybe a simple load balancer. Or, as you will see in the gory details of the model, you can go down to defining networks and subnets and ACLs and some stuff, frankly, you only need for very sophisticated applications. So again, it's a wide spectrum here. It's a pay-as-you-go. Enables you to have a true DevOps model where you are in control of your destiny. You can write the code quickly, and you can deploy it quickly, and you can change it and the environment around it quickly through effectively software. No hardware needed here, and no expertise, heavy expertise for networking is needed to get your applications done. So we have discussed before the Azure Resource Manager. At the highest level, in the very top, you have the service management APIs. So effectively, every resource in Azure has something called a resource provider, an entity that exports a bunch of APIs. And what's a resource? It could be an IP address for your network. It could be a load balancer endpoint. It could be a virtual machine. It could be a storage table, for example. These are all resources. ARM basically is a way to uniformly describe, through templates and imperative APIs, how you can compose application out of these resources, how they relate to each other, and how should they be deployed cohesively. It does the orchestration for you for your resources. And you'll see effectively every resource in Azure being exposed through ARM, through the same uniform fashion. And the concepts you see today for networking effectively applies to all resource providers. The RESTful APIs, the language bindings over them, and so forth. So the consistency is important, and the flexibility is very important. And note, guys, through ARM, you'll find templates. We're going to publish many of those templates. And the template describes an application, the topology of the application, all the resources that you need to make the application to actually come into existence. So you can start with an existing template, modify it to your needs, and the template may have some of the gory details that you can forget, or you can modify, okay? So within this model, we can also do the same now for one set of resources, which are the network resources. One more thing I want to, before I launch the networking per se, once you buy into the ARM model, you get a bunch of benefits that accrue to all resources in Azure. I mentioned the grouping function moments ago. So you can manage collection of diverse resources basically as units. The template will say, this is how they depend on each other, this is how they should be configured. When you configure this one, configure that one, and so forth. So it does a grouping function. And you end up with a consistent interface. The same architecture will apply both in Azure in the public cloud and on-premises as well. And there are other talks here and other forums that show you how effective the same model, the same concepts apply to either place. You also have, you end up with features that come in for all resource providers. For example, RBAC, role-based access control, where you can describe for each resource who can do what to it, who can modify it, who can just monitor it, and so forth. You get tagging on resources. We can attach tags to a resource and manage them that way. And of course, as with the other resources in Azure, you can decide in which region or location they have to live. So it's all under your control. Yeah. There are really three core resource providers that are very close to each other. And I will show you the object model and how they relate to each other in a second. There's a compute resource provider, which describes applications, basically, virtual machines, and so forth. There's a storage provider, which describes the storage dependencies of the application. And now there is a network resource provider, which describes the network topology of your application, and things like load balancing endpoints, and ACLs, and subnets, and as I mentioned, more details than perhaps you needed at the beginning. There are the dependencies between these, and you can put them in a very much a declarative model, these templates. And you see examples as well of this in a second. In addition to be able to describe them through a declarative model in a template, you can imperatively manipulate the resources. At the very bottom, like everything else in ARM, these are RESTful APIs. They are REST resources with RESTful APIs against them. And we have C# bindings, we have Java bindings, we have PowerShell, etc., which you can manipulate the RESTful APIs. Now, I gave you sort of the high level, what the resources are, how you depend on each other, and so forth, and how you can do it for the network. Let's talk about, this is one slide, very quick, so what features you can do to the network in Azure. And this slide predates the ARM model, by the way, so it already exists in a sense. But simplistically, apps live in virtual networks up in the cloud somewhere. You decide the location, and a virtual network, think of it as an envelope where your apps just can talk to each other, okay? It's isolated from everybody else. It's an isolation boundary, if you will. If you want to enter the isolation boundary, you have to effectively have, IP addresses in which you can go and enter the application set. And those IP addresses can do all sorts of things. They can be load balanced. You can put access control lists on them. You can do global load balancing through DNS-based system. When it comes to the internet, it comes through our infrastructure, which all the DDoS protection and so forth. So you have a virtual network up in the cloud. Your app runs in there. And you can reach your application through public IP addresses. This is very simplistically, guys. You can do a lot, by the way, within the virtual network. You can, if your application is sophisticated and you want to do subnetting or multiple tier or a front tier, talking to a back tier and the like, you can do so inside the virtual network. And the template I was mentioning earlier, the ARM-based templates, can describe the topology in a declarative fashion. And we're going to have a library of these, so you don't have to start from scratch. In addition, by the way, you can connect to your, this is advanced now, if you will. You can connect your resources in the cloud through back-end connectivity, either through VPN services, and there are scenarios for that, or for truly advanced scenarios, you can go through private connectivity, in which you can use a service from Azure called ExpressRoute to connect your customers' own premises to the cloud. That's a bit too much, perhaps, for today. But the point is, everything behind me here can be now manipulated through software, through the rest of the presentation. Everything behind me here can be declared in a simple template where you don't have to worry about much of this complexity, all the way down to declaring and managing subnets and ACLs and details as well. And lastly, we're going to give you basic templates to get you up and running, and then as you get more sophisticated with the application set, you can go define more and more details. Okay. So the rest of the talk is what APIs, what formats to use to actually manipulate this thing for the needs of your application. So using the network resource provider, which fits the basic ARM model, you can wire application wire the network to meet the application needs. You can do things like, for example, have simple bunch of VMs running the VNet, maybe with a public IP address. That's it. Or you can say, I want to have a load balancer. Again, it's virtual. That balances through some policy to a bunch of VMs. All the way down to having multi-tier applications with ACLs and so forth. And as I mentioned, all the properties I mentioned earlier, be it imperative, be it declarative, and so forth, applies to here as well. Okay, let's get into some details now. Here's a basic object model, and this is a simplified version of it, of the objects, the resources, if you will, in our model here. And there's a relationship between the storage side, compute side, and networking. But look at the networking side for a second here. The basic concept is, in the right-hand side, you see the virtual network. This is the resource in which your applications run, basically. And you can have subnets within the virtual network if you want to segment it depending on your application needs. If security is a very high priority within your application set, you can apply something called network security group. And Stephen will show examples of this, where you can apply policies for the subnets, ACLs on the subnets or on the VMs even. You can declare load balancers, in which you can have public IP addresses that are load balanced among a bunch of VMs. And you can go down even lower if you want to have the notion of a network interface. Multiple them per VM. There are scenarios like that as well. And there are more details as well. Okay, so Stephen, come over, please. Stephen will now go through the next level of detail here. We'll talk about the object models in some detail, and we'll show you the exact code as well. Thank you.
Okay. So, unfortunately, I don't have any laptops to give away today, but this is very interesting. So, we'll start working through. The object model we're representing here is the object model for the new core RPs within ARM. Those of you who are familiar with the current service management interface for Azure know that we've got two general flavors. We have PaaS and we have IaaS. And for PaaS, if you want to create a load balancer, for example, you get it automatically when you create a PaaS cloud service. You create the cloud service, you get your VMs, you get your load balancer, you get your public IP, all as one package. With IaaS, there's a little bit more control. You get your VMs, you get affinity groups, and you get a cloud service still. And you can specify the DNS on the cloud service. What that doesn't really allow you to do very well is to decompose that and only create what you want to create. So with this new model, we've decomposed all of these relationships into a completely modular framework. So here we're representing storage, compute, and network. Also in this ecosystem, not represented here, are like websites, SQL Azure, and various others in a growing ecosystem of resource providers, all of which have interdependencies, all of which are modular, and all of which allow you to create the applications and solutions the way you want to create them, which is awesome. Yusuf already mentioned about virtual networks, subnets, and load balancers. One slight, thank you, I just got louder. Load balancers, the same load balancer now can be made internal by just having no public IP, or adding a public IP, it becomes an external load balancer, it becomes a public load balancer. There's no change to the load balancer itself. All of this is on the front end side of the load balancer. So if you're testing something, then you can have your application there, you have your VMs ready, load balancer running, you're validating it internally, and then you're ready to go live with it. Add a public IP, expose it to the internet, add some network security groups to as network access control lists, and then you're good to go. Your customers can hit that endpoint straight away. So it doesn't require a new deployment, doesn't require any huge amounts of configuration. It just works. It's cool. On the compute side, just briefly, the virtual machines now have extensions. So you can have extensions created to create Puppet and Chef and PowerShell extensions. So these will run when the VM is created. So it's not just about getting a bare iron or like virtual iron with nothing on it. You can complete your solutions. You can have your deployments done into your VMs, into your new VMs, using Puppet, Chef, and so on, to get your application from Git, to configure, to build it, so that you can model your complete end-to-end application. So there's a lot of power here, and we'll dig into some of it here. Okay, so in terms of management interfaces, the foundation of everything we're doing here is the REST APIs. All of the RPs implement REST APIs that use JSON for request responses, REST semantics, and then everything else is built on top of that. We have XPlat CLI, we have PowerShell that talk directly to the REST API. They talk JSON, essentially. And then we have the various SDKs. We've got Node.js, .NET SDK, Java SDK, and others. There's, like Azure has a commitment to other communities such as Python, Ruby, and I can't remember the rest of them, but, and that's continuing. We're implementing support for these new RPs in all of these. So it's going to be, whichever way you want to manage, we've got you covered. Okay, so to dig into a little bit more detail, I'm going to take one example, and I'm going to run through a few examples of how we use this. Rather than look at everything and try to cover it to a very thin level, I'm just going to take one and go very deep. So what I'm looking at here is network security groups. As we mentioned in the last couple of slides, network security groups are basically a software firewall, allowing you to configure ACLs, access control lists, within your virtual networks to allow or disallow traffic. Great. The network security group is decoupled from network security rules, so you can have individual rules to allow or deny traffic. Fine. If any of you have ever seen a firewall, even a home firewall, you're used to the standard interface with having policies and in applied in priority order to either allow or restrict your traffic, which is great. The properties, do I have a latest pointer? I do. Properties here for network security rule are the ones you'd expect. I'm only going through this in a little bit of detail because we're going to be using this over and over again. I want to be sure that we all understand what we're doing. So properties here for a rule are protocol, TCP, UDP, source port range, destination port range. Is it HTTP? Is it ODP? Is it SSH? Is it whatever? Address and destination prefixes. So you can specify the source traffic, destination traffic, and for example, you can black hole countries and say, don't want to do that. Or you can open up to individual people, individual IPs, and saying, I want that person to be able to come in to use my service on that port. Access is just allow or deny. Priority is where it sits in the rule stack, and then direction is whether it's inbound or outbound. So now we have that. So looking at how we do this with REST. So up here at the top, oh, excuse me. Let me zoom in here. I don't think that's viewable. So up at the top of this screen, we have the method. We're talking about put here. With REST, there's put and post. We support put to either create or update. It is idempotent. It can be overridden if you wish by the use of a header, which is if match. And that works with e-tags to allow you to use it in either create or update modes, whichever you prefer. If you don't care, it works in either. So looking at the URL, we see that everything is stubbed off HTTPS management.azure.com, subscriptions, your sub-ID, resource groups, which we saw in the slides earlier. These are the containers that we use to manage resources within the ARM model. And then we have the namespace, which is Microsoft Network, and then we're talking about the network security groups here, and the network security group name, and then the version of the API we're using, which is great. So if we look at the request, we see it's JSON. It's simple. It's easy to understand. There's a defined schema for this, so you can validate it quite easily. The parameters are pretty much as you'd expect, all down here. And I've got sample values in there for allowing SSH. All pretty straightforward. So we see the protocol there is TCP, and the port range is 22. That's the destination port range. Because we're talking about an inbound rule, that means anybody from the internet coming in to hit that port is hit by this rule, which is great. And then on the destination side, on the response side, we see what comes back. After we send this over to the server, we see a couple of things. One, the name is now in the payload of the response, because this object exists. This object now has a unique URI, and the URI is this one up here, management.azure.com, blah, 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 and so on. It has an e-tag, and the e-tag allows us to use, to do concurrent control, concurrent access to this resource. So that we want to update, then we specify this e-tag in the if match header, and then if it doesn't match that exactly, the request fails. So that if somebody else is modifying the same resource at the same time, which is great. And then we have the security rules down here. Where are we going? There we go. The security rules. This is an array, a collection of the security rules we created. It's the exact same one we specified, with one addition, which is the ID up here, which is unique URI for this security rule within the parent. Great. Also at the bottom, we have default security rules. And this is worthy of mention because this wasn't in the request. This was added automatically, and it's the default property of network security rules that the security group is secure by default. So when you apply this to your subnet, when you apply it to your network interface card, it prevents traffic coming in from the internet unless you explicitly allow it. So this goes to address any concerns you might have about having your dev test environment, create your security group, apply it to your subnet, you're secure. Unless you open it up, there's no traffic getting in there. Okay, so move on to the next one, and we'll see the exact same thing, but with C#. And here I'm using, let me zoom in. Here I'm using the .NET SDK. The way I'm doing this here is that I'm getting an authentication token. I'm adding a token cloud credential. Down here is where it gets interesting. Microsoft Azure Network. Oh, there we go. Microsoft Azure Management.network .resource provider client, provider client. This one. Very long name. But this is the .NET SDK client that I can use to manage my ARM network resources. And it behaves exactly as you'd expect. I create a new security rule by itself. I'm not adding it to anything at the moment. Specify all the same properties. All happy. And then down here, I create a new security group, give it a location here, add a new list of security rules, and add the security rule that I've already created to this network security group. Fine. And then I pass it all over to the NRP client and say, create this, or update it, or whatever. And it does that. It sets that as the goal state for my operation. So I think the dev here is the resource group, just in case you're wondering. And then dev NSG is the name of the NSG security rules I want to create. So, or update. Cool. And now, going to the next one, we see PowerShell. The exact same thing again, I'm not going to dwell on this. I'm sure we're all bored of this example by now. So over on this side, we have, let me zoom in, excuse me. Okay, over on this side, we have PowerShell command. Great. New Azure Network Security Rule Config. Cool. We have all the same parameters we have down there. And we're just creating an object in memory here. It's not actually persisting anything to the server yet. And then underneath, we have new Azure Network Security Group. Give it a name. Specify the resource group name we want to create it in, the location, and then pass in this object as a parameter to say, I want this security group to have these rules. Cool. And on the output side, which is kind of interesting, we see, okay, the name of the network security group we created, great. The location, fine. The unique identifier, this is the big, long management.azure, so on. This can be used then in further updates, creates, or in dependencies, and I'll talk a little bit about them later. E-tags, and then security rules. And here we notice that this is JSON. So as I was saying earlier, everything about the interfaces you're going to use to talk to ARM is about REST and JSON. You can deal with XPath, you can deal with Java SDKs. Underneath, they all get translated over to JSON. So, okay. And then at the end, we'll see a couple of references there just to mention them. Default security rules, we mentioned that. Network interface and subnets. These are any network interfaces or subnets that have been configured to use this particular group. And we haven't done that yet, so they're back. Okay. Okay. So, REST operations that are supported, again, just using this example. For network security groups, we support creating or updating through put. We support getting through get, obviously, listing through get as well, and then deleting through delete. The relative URLs, these are all relative to the management.azure.code. And these are for put. We leave it blank. Oh, sorry, we put in the NSG name into the URI that we're posting to, or putting to, excuse me. And for get, same thing. For listing, we leave it blank. We just get all network security groups in, and then we can filter in client side if we want, or get that collection. And then deleting has name as well. Predictably then, JSON request response for puts. We don't specify anything for getting or listing. It's only DRI, and then we get JSON in response. And for the delete, we have no JSON, nothing in the body, and then we got a status code, like 200 or 400, or depending on whether the object was deleted or whether the object was couldn't be found, didn't exist in the first place. And then just briefly to touch upon this, which is the bottom of the table here, network security groups is an object or a resource that contains network security rules. So how that semantic works within the ARM framework is that when using these verbs to access child resources, essentially, then we just append the name of the child or type of the child, security rules, and then the name of the child we want to either create or update, get, or list. That gives all of the security rules then we have configured for this network security group. So that's all fine, and then deleting is the same. It's all pretty predictable, but just for completeness, make sure that's there. Okay, so a number of items are provided Azure-wide, as Yusuf mentioned, for resource providers that are implemented in ARM. One of the things that's implemented is getting audit logs. So this is an example of how we can use this feature that's ARM provided to get audit logs from a particular scope. And the scope we have here is a network security group. So then we go off and say, well, who's modified this security group? Who's changed it? Who's added? Who's deleted? Who's whatever? And this allows us then to get that detail. Similar functionality is there for ORBAC and tagging as well. So using the same ARM-provided structure, we can specify that we have, just to explain what ORBAC is, we can specify that certain user groups have access to certain resources or certain paths, and certain others don't. So then if you wanted to create something yourself, make sure nobody else messed with it or whatever, then ORBAC is the way to do it. Okay, templates. Templates, I'm not expecting you to read this right now, so please don't strain. I'll zoom into a little bit in a second. Templates are really awesome. Templates allow you to specify multiple resources in one file with dependencies, with support for parameters, with support for variables, and with support for looping within the template. So, for example, you can have one template file, if you want. I'll talk a little bit about that in a second. You can have one template file that will have your virtual network, your subnets, your network security group, all the things we talked about, plus a load balancer, VMs, virtual machine extensions that would deploy your application into your VMs, and also the public IP to expose that load balancer to the public, and have all the dependencies between them and all the dependencies that you might have between, for example, Azure websites and them as well. So the critical things to look at here are, it's JSON, fine. There's a defined schema. And then we have parameters, variables, and resources. Parameters are user provided. We have support for default values. We have support for input masking in terms of regex and so on, and native types as well. And resources, great. Resources are, as we said, a collection of resources from across the resource providers. I'm not just talking about networking. And other interesting things we have down here. Do I have any? Yes, here's one. We see depends on. That's interesting. So we have a network interface, and we're saying, well, this depends on the virtual network. So the virtual network, therefore, conceptually, must be created before we can create a virtual network within that virtual network. These are queues that ARM reads, so it can deconstruct the template into a dependency graph, and then parallelize those requests to the various resource providers to make sure that, one, we don't get ahead of ourselves and try to instantiate something that we can't instantiate yet because the parent doesn't exist or dependency doesn't exist, and two, to maximize efficiency. So we get maximum throughput, minimum time executing template, and all the parallelization gets done at the ARM level, as opposed to you having to figure out what's the best and most optimum way to do it yourself, which is fun. Okay, so we have lots of things here. I'm not going to spend too much time on this because we're going to go through a bigger example in a second. But just to call your attention then on the PowerShell, to use this template, this is all we do. We have PowerShell, new Azure resource group. We also have support to do this in XPlat and so on. And specify the name, the template file we want to use, what region we want to deploy this into, and then the name parameters that we want to pass in values for. Before moving on, I just want to mention one quick thing, and that is how you create template files is totally up to you. I've got one template file here, and it's got virtual networks and subnets and security groups and various other things. And that might be fine. That might be, suit your purposes, fine. But you might want to separate it out and say, well, I want to keep my DMZ as one template. I want to have my backend as a separate template. So that you don't have like single files that are really, really big, and that's very, very difficult to see what's going on. And you can deploy all of them into the same resource group. You can then manage those particular layers of your application as atomic units by either updating the template, reapplying the template, and then the goal state gets reset or updated for the resources contained within that template. But if you specify something in a template, and then sometime later you remove it from the template, it doesn't get overwritten. It's still there. So the template doesn't reset the whole thing, doesn't reset the whole goal state. It only resets what it knows about and what you specify in the template. So if you're not going to accidentally wipe out other resources by applying a template to a resource group. Okay. Okay, I think I've probably talked enough about PowerPoint. So let's have a look at some of that in action. Give me 1 second. While I log in. Okay. Hey. Okay. So switching it over so you can see what I'm doing. Cool. Okay. So here we have a template, and we have the same kind of structure we saw a second ago. We have parameters, variables, resources, all fine. Can everyone see this, by the way? Is it too small, or is it okay? Okay, cool. And we have types, we have names, locations. What are we trying to do here? So in this template, I'm trying to create a virtual network, a network security group, subnets, load balancer, a couple of VMs, and a public IP on the load balancer, and then I've got some interesting things on the network level down at the end. So if I look at, expand out the load balancer, expand out the properties here, we see a lot of things here for load balancers. We see front-end IP configs, we see back-end address pools, load balancing rules, probes, and inbound NAT rules. So this is really a very configurable load balancer that allows you to control the traffic as it goes through and into your backend. An interesting thing as well is this, inbound NAT rules. This allows you to specify tunnels basically through your load balancer using port address translation to have an outside port that then gets forwarded to an inside port. Here, for example, it uses an inbound NAT rule to forward traffic for ODP 3389 into a particular VM in the backend. Other ways of doing the same thing will be to have a virtual network, a VPN on your virtual network so that you can access everything privately, or having a public IP directly on your VM so you don't have to do inbound NAT on a load balancer, which is great. And one other thing then to draw your attention to here is the dependencies. So this load balancer is dependent on the virtual network, and it's also dependent on public IP, which is cool. Okay, so we know what I want to do here. We have a template, so let's just have a look and see if we can get this deployed. Excuse me. Okay, so here I have a PowerShell, and just making sure that this doesn't already exist, fine. And I have all the parameters required to run this template. I'm just creating a password for the VM. It's random. And then specifying the resource group name I want to use, which is sample app dev, the template file I want to use as well, location, subscription ID, name prefix. I've just done this to make sure that I don't have to repeat the same thing over and over and again. I'm using variables in the template to then create the names of all the resources I want to use, so that they're all prefixed with ws-dev-vm1, for example. And storage account name, that's where the VHDs are going to be stored, and the public IP address name. This is interesting. We'll look at this in a second. And then the admin name and password. That's fine. So where is my cursor? I'm on the wrong machine. OK. So let's just run this and see what happens. OK, hasn't crashed yet. We're good. Sorry, bad joke. So here we see we've asked it to create this application. ARM has accepted the template. That says valid. Great. What it's doing now is it's breaking down the dependency graph for the resources I've specified and is figuring out what's the best way to do this. It's then going to go off to each of the RPs with as much parallelization as it can, so that it's not just about, oh, well, these are network, these are compute, and these are storage, and then calling this, this, and this in parallel. It's saying, well, OK, well, I've got 2 VMs here. I want to call that in parallel. I want to call the compute resource provider twice in parallel to create my 2 VMs in parallel, instead of having to do one and then wait and then the other one and then so on, which could quickly and easily get very onerous from the point of view of spinning up environments. So that's all running. You're seeing a lot of success here. All these things are fine. No problem there. Now I want to switch over. Actually, before I go there, we'll leave this running and switch back to, done it again, switch back to the template. OK, templates are great. They really are. They're awesome. But there's a lot of text and a lot of different resources and different schemas and so on. This could be a bit of a problem, a bit of a challenge from the management point of view in creating these initially and then editing them as you go on. We already saw the PowerShell response was JSON, and we'll see a little bit later that the objects are JSON as well. Everything is JSON. So there's nothing to stop you going in and creating your objects using the like PowerShell or .NET SDK, and then using the JSON you get back from those requests to create your templates. A different way is to, let me bring this up, is to use canned templates that we've created. Oh, excuse me. OK. Excuse me. Is canned templates we've created. This command will go to the Azure Resource Manager template library and will list out the templates that we've created in this library that you can use. And they range from SQL Azure to, what else did I see in there? Websites, networking, and various other things to give you a head start into the applications, the template applications you want to create. Let's go. And let me just open a new one of these, and I can show that in action. Excuse me. This will just take 1 second. Apologies. It's only a minor fail. OK. The first command I executed there is to switch to Azure mode of the PowerShell commandlets. And that switches the PowerShell from using the service management APIs that you're using now to the ARM templates as well. It loads up all the PowerShell commandlets. OK. OK. Nearly there. Voila. OK. So while that's doing that, want to go back here. I want to show you these templates. And so select my subscription, and then show you the templates that are there, which is good. So over on the left-hand side, we should then start seeing a list. So there's a lot of templates there already. These are there to give you a head start on your application templates. And in addition to that, there's also quite a large library of templates available on GitHub. These are created by either Microsoft internal or MVPs, and we expect this to grow quite rapidly as people start creating templates to cover different scenarios. We have templates here already for, like, obviously creating load balancers, but also creating your VMs with Puppet and Jeff and all these lovely things to install things after the VM is created. So that's fun. So switching back then to the deployment we had going. So we've got this going already, and we're not going to wait for it to complete. But I've done one earlier, and I'm going to show you what it looks like. Here, I've created one of these already, earlier on today, and it's for a stage application. It's the same template. It's got the same resources. All I did was change the parameters. So here we have virtual machines. Let me show these. We've got two virtual machines, and again, ws-stage-vm name1, or VM1, excuse me. And here we have the full JSON defining this VM. We have the availability set it belongs to, the storage profile includes the PhDs, and we have the network profile, which is the network interface. As we saw earlier with the object model, the network interface is now no longer automatically created as part of the virtual network. It's separate. You can manage it separately. You can move a network interface to a different VM. No problem. And then we have the other one, which is the same, just got a different name. Looping is a way within templates. I haven't done this for this example, but it's a way for you to create multiple objects of the same type with variances just in name. So you can have like VM1, VM2, VM3. So looping is the way to do that. And you can create, for example, then 50 VMs in your load balance set in the space of a few minutes. It's all good. Then we have the Microsoft network namespace with all the objects in here, which is great. And in here, we have a network security group. And we have a network security group with no security rules. So we've seen earlier that a network security group with no security rules will block everything, which is great. However, this is my stage environment. And I'm kind of thinking that I want to open up the stage environment to customer to let them have a look at what I've done. So if I switch back to here, excuse me. Oh, and actually that's all finished. That's awesome. So the template we started running a couple minutes ago, is done. This dev environment is there with the two VMs, the load balancer, the various other stuff, which is pretty awesome. Now, looking at the stage environment we created earlier, I want to have a look at the public IP, because I want to be able to give this public IP to a customer and have them RDP into this into one of these VMs to have a look and see what my stuff is doing. And I see that I specified, let me scroll over, I've specified the domain label here as NRP website stage. Great. ARM then translate this, network resource provider then translate this into this DNS name, NRP website stage East US, being the region I'm deployed in, .cloud.azure.com. DNS is optional. I'm just using it here for convenience. You don't have to use DNS on public IPs, totally up to you. You can use the IPs, and we don't force you to create it. Reverse FQDN is an interesting one to point out as well. Public IPs support the creation of PTO records to enable you to host mail servers and other things like that that might require PTO records, excuse me. So I've copied that. So I want to have a look and see, well, is this port open? Is 339 open? So So I'm using a tool here that is a tool, I think it's developed internally in Microsoft, and it basically does a ping using TCP. It makes a connection and then tries to connect in that port. Very similar to the ping tool, but I didn't fancy trying to get ping to work from here. Okay, so we've pasted in the destination name. The port I'm trying to hit is 3389, and we'll go with that. That's a problem. So I want to give this to a customer, but he can't connect to it. So what can I do about this? I look at the thing I created earlier. Okay, no security rules, so I'll create a security rule. So everything we've looked at so far in terms of templates has been declarative. We've modeled our resources, we've modeled the dependencies, we've sent it off to ARM, and it created everything, all declarative, which is awesome, it's great. Sometimes you want to do imperative as well. Sometimes you want to, well, this stuff is great, I just need to do this little thing. And that's where you can do stuff imperatively. You don't have to use declarative. You can do everything imperatively if you want to, or you can do everything declarative and never go near imperative. It's really whichever way you want to do it, whatever works for you. Here, I've got a Visual Studio application. And I'm going to go and create that security rule that I'm missing to allow 3389 inbound to allow me to connect. All the while I'm doing that, I'm going to leave, where's it gone? This command line up. This is constantly probing this endpoint, trying to connect, trying to connect, trying to connect. So all going well, when I execute this code, this will start connecting. So we'll see how lucky I feel. Okay, so we've already looked at a bit of this. I'm going to make this a little bit bigger so we can see it. Same code we looked at a couple of seconds ago on the C# slide. We're instantiating management to Azure Network client, basically, to execute this. We're doing something different here. We're not creating or updating from new. We're getting something that's already there. So I'm passing in the resource group, and I'm passing in the object I want to manage, which is the WS stage NSG. This is the name of the resource. Oh, excuse me. This is the name of the resource group, or the network security group I want to retrieve. So let's start with this. Okay, sorry, I need to do this. The authentication model I'm using forces me to do this, so. This will take a second. Okay, cool. Moment of truth. Step over this. Didn't fail. Good. Sorry, I've got absolute confidence in this. There's no problem. So now we retrieved a network security group. It's a collection. It's the object that I created earlier, and created another one now, containing the network security group and the rules. The rules are a bit non-existent, so we need to rectify that. So stepping over this, creating a new security rule, same structure we saw before. We have, where's my cursor gone? We have all these properties specified normally, fine. Specifying a port range this time, between 3389 and 3390. And stepping over this, we're adding it to a collection of rules in the network security group we've already retrieved. And moment of truth, we're going to put this back on the server. We're going to put this back to ARM. So this will take a second. Cool. Okay. Stage response code is okay. It worked. And then we stepped into the exit thing to return true. Fine. What do we expect to happen here? One, we expect to see that if I switch back to the Azure Resource Explorer, sorry, I didn't introduce this. This is a preview tool that allows you to look at all your resources, look at the JSON for creating and for deleting and so on. It allows you to create stuff right here. You can create new ones through the actions. You can delete them. And you can experiment with your JSON. You can experiment with the resources. Or you can just use this as a very, very handy helper for creating your own templates. Creating an object, creating a resource, going in here, looking at the JSON, copying out your template, and then go from there. So if I go here and if I refresh this, one, I expect to see the security role. Okay, let me just go back. Excuse me. Okay, sorry, didn't like that. So expand this, this one, resource groups. A lot of things in here. Stage. Stage is the one we did earlier. And we look at network, and we look at security groups, and there, that's the role. That's the one we just created. Awesome. Here we switch back here. Oh, hey, this is the command line that has been constantly pinging this endpoint. And we see that as of around a minute ago, it's connecting. It's working. The rule has been deployed. The network firewall essentially has been updated to allow this traffic. And I'm now able to connect. And that means I can give this to my customer. He can connect. He can have a look. And it's all fine. So that's all as we expect. So to switch back then to the presentation. Okay. So we started with, why do you care about this? And just to recap, we want you to liberate your development testing experiences by enabling you to manage these resources and to create these end-to-end applications in a very, very lightweight and consistent way. You can use the same interfaces to manage resources in storage, in networking, in compute, in websites. It's the same type of interface, REST and JSON. It's consistent across all of these and delivers value adds such as ORBAC and tagging and so on that are developed centrally on the ARM platform, enabling you to have a better experience. It enables you very, very easily to have repeatable experiences, repeatable deployments for your dev test environments. And it represents the best-in-class infrastructure and consistent interfaces, fast provisioning, and massive scale, of course. Basically, it allows you to turn your code into networks, if you want. Whichever way is easiest for you to work, if you want to use code, if you want to use XPath CLI, if you want to use Java SDK, if you want to use Node.js, it's all fine. It's whatever works for you. And you can have this in near real time. You can have it configured exactly as you want without any onerous process associated with those changes. Okay, so we're coming up on time. I just want to leave a couple minutes for questions. So, call to action. There's a number of talks on today that are really awesome, over the next couple of days, they're really awesome. Mark Krasinovich's talk is scheduled for this slot, so you can't obviously attend, sorry. But I advise you to have a look at that if you get a chance at some point online. And then we have a slot this evening, which is Introduction and What's New in Azure IaaS. That'll talk a lot more about the compute side of the ARM and the resource providers. It would be awesome. And then another good talk tomorrow with Mark Krasinovich, lessons from scale, building applications for Azure. And then on Friday, Azure Virtual Machines Deep Dive. That's going to be a pretty cool talk. Again, on the compute side, but if you want to have a look at compute and extensions and so on, then the compute talks are certainly worth checking out. And go try them. Like as of today, we're public preview. So these are freely available to use. There's no sign-up required. The resources underneath are GA resources. So you will pay for the resources. So if you have Microsoft MSDN Azure subscriptions, I advise you to play around and use up those credits for getting your hands on with this. Pardon? Okay, sorry, pardon, yeah. The resources underneath are the virtual networks and so on are GA, but the resource provider is, sorry, I thought it was clear, is public preview today. That's just the management interface sitting over these resources, but the resources themselves are rock solid. And take control of your networks and do it as you want to do it. Okay. Just a couple of tidy up slides, a couple of resources there. If you want to try out Microsoft Azure, check it out. It's cool. And then please evaluate. It helps us get better. So any comments, appreciate it. So thank you all for your time. Any questions? Cool. One question in front.
This is kind of feedback. So one of the things we got wrong is that if you do declarative, if you do template, if you do imperative to like remove one of those groups,
Mm-hmm.
then that changes the logs, right? So it seems like it might be worthwhile to actually have the actually saved in the template, so that you can keep that history, you can pass that history.
Okay. Just repeat because you're not on the microphone. A feedback item or suggestion is to, when we're using declarative and templates and when we create a bunch of objects and then we imperatively delete something, then potentially that change is then lost. So the suggestion is that we somehow track that change, that imperative change, to the template, either server-side, I presume, or somewhere. And then give the option to replay those imperative changes that have happened to a declarative template at some point after that. It's an interesting suggestion. I'll certainly bring it back to the team and see what makes sense. So.
Is the other method to export your as template?
Yes, yes.
Put that into your source control and then
Yes, and the follow-up there was that the alternative would be to create everything with your declarative template, execute your imperative changes, model everything back then again to a template, save them to your source control, and then your source control then has most up-to-date template. And that's another option as well.
I mean, what you're pointing out is declarative model is much better, of course. The imperative stuff is useful if you control the runtime. Exactly. Yep, I agree.
Yeah. Cool. Thank you. Very valuable feedback. Anybody else? Okay, I can't see anybody with those hands up. Okay. Okay, well, thank you all for your time. It was great presenting here. Have a great build, have a great day, and enjoy your laptops. Thank you.